So in this microcontroller programming and in today's lecture what we are going to learn is what is microprocessor or what is a microcomputer. Excuse me, unable to share the screen. Yes. So what we are going to see today is what is microcomputer. What is microcomputer and the block diagram of a microcomputer and the function of each block of the microcomputer. Next we'll see what is a microcontroller, and next we'll see what is the comparison difference between microcontroller and microprocessor. Application of microcontroller. So when we are seeing this slide, we are seeing many new terms here. One is microcomputer. Everybody knows what is computer, but what is this microcomputer? And we are also seeing one more, a new term here, microcontroller. And also we are seeing microprocessor. So what are all these? What are all these? So that we are going to see now. So what is computer? I think all of you know what is computer and what it will do. So what is a computer? As you can see, a computer is the one for which you are giving some data, some input, for which we are giving some input, and the computer will do some processing on it. That means it will modify the data in some modify that input in some way, and it will give you as output. So if you see the basically what is meant by this input and what is this output and what is how it changes the given input to output. Okay, you can see the block diagram at the top. So there you can see that if you see, this is a block diagram of a normal computer, where you will see what you will see in the computer. When you look at the computer, there is some monitor, there is some CPU box, and there is some keyboard and a mouse. These are the things that you will see common when you see a computer. And you can see that what is the use of monitor, what is the use of keyboard, or what the keyboard will do and what the monitor will do, and what the box we call so-called CPU box will do. What it will do. So through keyboard, what you are doing actually, what the keyboard, what is the function of your keyboard? So through keyboard you are entering some information, some input. You are giving some input to your computer. Maybe certain instructions which tell what the computer has to do. So you are giving some instructions through the keyboard. In a similar way, you are giving some data. Data means the information that you want to modify. For example, you want to add 2 plus 3. So you want the computer to add 2 plus 3. So what you have to give? You have to give the data. So these 2 and 3 are called as data. So we'll give the number 2 to the computer and number 3 to the computer, and this is called giving information or giving the data to your computer. And you have to instruct the computer to add those two numbers. So that is called instruction. Okay, you have to also give the instruction to computer also. So through keyboard, what you are doing actually, you are giving the data, that is 2 and 3 numbers, and we are also giving the instruction. That means to add those two numbers. This is the instruction. So my keyboard here, it is called as input unit. Input unit, that you can see in the block diagram. So by using input unit, what I am doing is actually I am giving inputs to my computer. Giving inputs to my computer. The input may be the data or instructions. And where these instructions and data are going, you can see that this data and instructions are going into the so-called CPU box. What is there in the CPU box? Then you can see that there is a central processing unit. Central processing unit, and you know what this central processing unit is, which contains a control unit, arithmetic logic unit, and memory unit. So whatever the instructions and data that we have given using our keyboard will go and store in the memory first. And there are some arithmetic logic unit, and these arithmetic logic unit are going to perform the arithmetic operation here, which is addition. Okay, and whatever the result it will get, what is the result? It will get 2 plus 3, it will get as 5. Okay, and that must be given to us. That must be the result of the operation must be given to us, and that is given to us by using this output unit. And here the output can be anything. That means the result 5 will be displayed on the output unit, say monitor, or it will be printed using your printer. Okay, so what I can say that this is the basic um, function of your computer, and how it will actually accepts information through input unit and process using your central processing unit and give output using your output unit. So what is a computer? Now I can define it in this way: a digital electronic device that accepts information as input and process it with a set of instructions. So మనం ఏదైతే ఇన్స్ట్రక్షన్స్ ఇచ్చామో ఇన్స్ట్రక్షన్స్ ఇన్స్ట్రక్షన్స్తో ఇన్స్ట్రక్షన్స్లో ఏం చెప్పామో దానికి తగ్గట్టు ప్రాసెస్ చేసి will produce a result as output. So this is what is the basic definition of your computer. And you know that we are calling it as digital electronic device because it just understands only ones and zeros. That is, it always thinks in the language of binary. That means we are the humans, we may be understanding certain other languages, English, Telugu, maybe Hindi, etc. etc. But what is the language that is understood, or in which your computer actually works, is binary language. That means it knows, or it the information only when it is given in terms of ones and zeros. That means whatever the information, whatever the input that you are giving by using mouse or keyboard, you should give it in the form of ones and zeros. Or the information given by your input unit should be converted to ones and zeros before it is given to your computer, because computer understands information specified only in terms of ones and zeros. Okay, so this is what is computer mean. Okay, but what actually we require, what is a microcomputer? So what is the difference between a computer and a microcomputer? The difference lies here with respect to your CPU. So what is there in the CPU? CPU have control unit, arithmetic logic unit, and a memory unit. And if you take a normal computer, all these control unit, arithmetic logic unit, memory unit will be separate circuits. Will be separate circuits, and you need to connect one to the other to make this complete CPU. To make this complete CPU. But in so-called microcomputer, In so-called microcomputer, this entire CPU will be on a single integrated circuit. In so-called microcomputer, this entire CPU, which contains control unit, arithmetic logic, memory unit, will be on a single IC. You know what is IC? An IC is a set of electronic circuits on a small flat piece of semiconductor material. If you take one, you can see the picture of IC here. You can see the picture of IC, right? So that means all these circuits which constitute your CPU, if they are placed on a single piece of semiconductor material, then that CPU we are calling it as microprocessor, right? Again, I'm repeating. Normally, CPU in a computer consists control unit, arithmetic logic unit, memory unit as separate circuits or separate ICs. And if all these three which constitute your CPU are built on a single piece of semiconductor material or are built on a single IC, then that CPU will be calling it as microprocessor. And if a computer which uses this microprocessor as CPU, then that computer will be called as microcomputer. Okay, so the difference between a computer and microcomputer comes with respect to how the CPU is made. Okay, if the CPU is made on a single IC, then it is called as a microcomputer. If the CPU is made with the different circuits or circuits on different ICs, then it is called as computer. Okay, so this is the difference between your computer and microcomputer. So next we look at the block diagram of a microcomputer. You can see the block diagram of a microcomputer. There is an input device, there is an output device, and there is a microprocessor. There is a microprocessor. This is a single IC that we have shown in the previous slide. So like this, you will find a single IC wherein you will find the arithmetic logic unit, control unit, and register array all built on the same IC called microprocessor. Okay, and next we also have another block that is called memory unit. So what are the various parts of your microcomputer? You can see that there are three parts of microcomputer. One is your CPU or your microprocessor and a memory unit and input device and an output device. And what is the function of each? What is the function of each? I already given information to you while explaining the block diagram of your normal computer. Okay, so I will repeat the things. So input device, what is the purpose of input device? The computer actually receives, the computer means this microprocessor actually receives data and instructions through input device. సో ఈ కంప్యూటర్ ఆర్ మైక్రోప్రాసెసర్కి ఏదైతే డేటా కానీ ఇన్స్ట్రక్షన్స్ కానీ అవసరం అవుతాయో, ఫర్ ఎగ్జాంపుల్ ఇఫ్ ఐ ఆస్క్ ద కంప్యూటర్ టు పర్ఫామ్ ద అడిషన్ 2 + 3, సో what the computer or microprocessor requires, it requires the data which is 2 and 3, and it also requires the instruction. What is that? What to do with 2 and 3? What to do with 2 and 3? When it receives the data 2 and 3, what it has to do? That we have to tell. Okay, that we have to tell as an instruction, that you have to add those data 2 and 3. So telling that you add the two numbers is the instruction, and giving the numbers refers to the data. Okay, so here numbers refers to the data, and telling that you add the two numbers is an instruction. Okay, so Microprocessor here requires the data and instructions, and the data and instructions are given are actually received through input devices. Okay, so that is the function of your input device. And I already told you that the microprocessor or a computer is a digital electronic device. That means when we are giving the instructions, we will give the number 2, number 3 from your keyboard, and whatever the instructions that we type in English. Okay, but your computer neither understands the decimal numbers called 1 2 3 4, and neither it understands the English language alphabets ABCD. Okay, so what it just understands is ones and zeros, ones and zeros. So what we have to do is we have to convert the alphabets and the numbers into the binary form where you will see an equivalent binary number for every alphabet, for every digit, decimal digit. Okay, so for example A, it is represented with some series of ones and zeros, 8 group of 8 bits, 8 um, bits. That means a combination of ones and zeros, group of 8 ones and zeros. Okay, so that means the input device, it also has another function that it converts whatever the instruction that you type from the keyboard or a data that you give from the keyboard into proper binary form suitable for your digital computer, because computer only understands the instructions and data in the binary form. That means every alphabet, every digit must be converted to a series of ones and zeros that your computer or microprocessor can understand. Right? So from the input device, what we are giving data and instruction to your microprocessor. But before giving the data and instructions directly, the input device is also responsible for converting them into binary form. Okay. So what are the examples of input device that you can see? A keyboard is an input device, okay, through which you are actually giving the data to your instruction to your microprocessor. Next, so you have given some instructions and some data to your computer. Are those are directly taken and processed instantly by your microprocessor or computer? That means you two and three data each other, and you are giving the instruction that you add the 2 and 3. ఈ డేటా ఇన్స్ట్రక్షన్ తీసుకొని ఇమీడియట్గా కంప్యూటర్ అనేది is it going to add? No. Okay, so before it will not take the instruction and data directly and it will going to add, but it will store the data and instruction somewhere. Okay, so ఏదైతే మైక్రోప్రాసెసర్ ఉందో, once we are giving data and instruction through your input device, it will first store the data and instructions in the memory unit, which is provided separately outside your microprocessor. So the memory is actually used to store the data and address and instructions in binary form. Okay, so the input device actually given the instructions and data in binary form, and all those instructions and data are first stored in the memory unit before they are processed by your microprocessor. Okay, so the purpose of memory here is to store the data, address or instructions in binary form. Okay, so but there exists two different types of memories. One is called random access memory, other you know it is read only memory. So which is permanent memory, which is temporary memory? In this, RAM is a temporary memory, ROM is a permanent memory. So then a temporary data which is temporarily used will be stored in your RAM. The data which is to be stored permanently will be stored in your ROM. Okay, So RAM stores the data temporarily, and ROM stores programs and some information which is required for operation of the computer permanently. Okay, so that is the use of your function of your memory. So next, so we have given the instructions and data through input devices, and it converted the data and instructions into binary, and those are actually stored in your memory unit before they are processed by your microprocessor. So after storing the data and instructions in the memory unit, next what is the step? Those data and instructions must be taken by your microprocessor. Okay, so that is CPU or microprocessor. What it will do? It will take the data from the memory, and it will also take the instructions. Data means here in our example, it will take the number 2, decimal number 2 and decimal number 3, which are stored in binary form. And it will also take the instruction from the memory. What is the instruction given to it? That you add the two numbers. That is the instruction which is also stored in binary form in your memory. So microcontroller takes this data and instructions from the memory, and it will process the data and instructions. Process the data and instruction means it will read 2, it will read 3, and it will read the instruction. The instruction tells it that add 2 and 3. So it will add 2 and 3, and it will get the result as 5. Okay, it will get the result as 5, right? And this it will keep with it so that it can be given to output device. Okay, so before going that, you see that what are the major components of your microprocessor. You can see that the microprocessor has ALU, control unit, and register array. ALU means arithmetic logic unit. That means this is the unit that is responsible to perform arithmetic operations and logical operations. And we have one more thing, that is register array. This is used to store the results temporarily before they are given to output device. That means in this example we got 2 plus 3 as 5. Okay, so after getting 5, immediately it cannot give to output device, but it has to store somewhere inside your microprocessor, and where it will store is in some registers that are present inside, and that is called register array. And it also has some other circuit called timing and control unit, and this timing and control unit circuit is responsible for controlling all input and output devices and memory. Okay, right. So the CPU is responsible for performing all arithmetic operations and making the logical decisions by the computer's program. Okay, so once we got the result as output as result, it is stored in the internal register array. Next, it is to be given to your output device. Okay, after processing, you got the result, and that result must be given to your output device. So the computer sends the processed data or the results. Processed data means the results. 2 plus 3 equal to 5. 5 is the result or processed data. And this the processed data is sent to the output devices. What is the output device then? Output device may store the result, or it will print the result, or it will display the result, or it will send the result to some other equipment. Okay, so the output devices can vary in a different way. Some devices may store the result, some devices may print the result, some devices may display the result. And you know what are the examples of output devices? You can see that the monitor that you are seeing in a computer is an output device, and what it will do, it will display the result. And one more output device that you normally see is your printer. Okay, printer. And what it will do, it will take the result from CPU and it will print the result. Okay, so these are the actual various blocks of your microcomputer. You can see that the input device and a microprocessor, then output device and a memory unit. Okay, So whatever the data instructions required are actually received from input device in binary form, but first they will be stored in your memory unit, and after, once the microprocessor is ready to process the data and instruction, it will take the data and instruction from memory unit. It will process the data according to instruction, and it will get the result. The result is stored temporarily in the register array, and when it is ready, the result is given to output device. The output device may either print the result or display the result, okay, or store the result, okay. So this is how a microcomputer will actually function. So next we look at what is a microcontroller then, okay. What is a microcontroller then? So before going to this microcontroller, just look at your microcomputer again. So microcomputer lo what is there? Microprocessor is there on a single IC. Apart from this, it requires an input device, it requires an output device, it also requires a separate memory so that it will function as a computer. Okay. But here, what is a microcontroller? You can see there is a diagram at the top which shows that microcontroller is also an IC. Also an IC means a circuit made on a sheet of semiconductor material. Okay, IC, I think all of you have done digital electronics lab where you have seen a lot of ICs and gate ICs. So it's similar to that IC. The microcontroller is also an IC, but where inside you will find a circuit, and that circuit contains your microprocessor. That means the middle block, but it not only contains the microprocessor on the same circuit, but it also contains memory and other circuits on a single IC. Okay, so microcontroller is also an IC, but it contains not only your microprocessor on it, but it also contains a memory and other circuits. Other circuits means you can see here in the diagram it is shown that the same controller IC contains the CPU, contains the RAM, ROM, and IO, input and output, and also ADC means A to D converter, and DAC means D to A converter, and a clock. All these, see, they are showing actually ICs, but all ICs are not put into the single IC. Don't mean that. All these circuits are existing in this one IC called microcontroller. Okay, so the difference is that microprocessor means only the CPU, only the CPU circuit will be there on the IC. Microcontroller means not only the CPU circuit, but it also has RAM circuit, ROM circuit, and also other circuits are also present in a single IC. In a single IC. Okay, so that is what we call it as a microcontroller. So what is the use of microcontroller then? So microcontroller, what is the use? You have seen a lot of appliances at your home. Okay, I have seen a lot of appliances at your home. They take for example a washing machine. Okay, so there if you see, you can set the water levels, or you can set the spinning time, that means, or you can set the washing time. Okay, so for example you are setting the washing time as 15 minutes or 30 minutes. Then who is actually monitoring this time, and who is actually controlling your washing? And that is called as a microcontroller. Okay, that is called as a microcontroller. But a microcontroller here cannot perform all the functions of your washing machine. How many functions your washing machine has? A number of functions. Okay, one function is to monitor the washing time. One function is to monitor is the water level. One function is to monitor the spinning time. Okay, and other function is to um, perform a task like um, availability of water, okay, from the tank, etc., etc. So there are number of tasks that are to be performed in order to work the washing machine. Okay, so here for every task, number of tasks are there, right? So for each and every task you can use a small IC. You can use a small IC or a microcontroller. Why you can use only microcontroller? Because microcontroller contains all on the same IC. Okay, all on the same IC. So microcontroller here performs a specific task, and that means it controls some of functions of your electronic device. Say for example your washing machine, or for example if you take a micro information, you are setting the menu. Okay, menu or the amount of temperature, and which is displayed on the outside panel. Okay, and who is doing all this is your microcontroller. Okay, and for example you are operating your remote control. Okay, and that means you are sending some signals to your TV, but who is actually receiving the signals in your TV? It is again a microcontroller. So it receives the signal and it performs a certain task, that changing the volume, changing the channels, etc., etc. Okay, so this IC, so-called microcontroller, is actually used to perform only a single task, only a single task, and it does not require any other memory and any other controls, any other devices, etc., because it contains all in the same IC. Okay, so normally where it will be used, the microcontrollers are used in automatically controlled products. సో ఏవైతే ఆటోమేటిక్గా కంట్రోల్ అయ్యే అప్లయన్సెస్ ఉంటాయో, ఫర్ ఎగ్జాంపుల్ వీఆర్ సెట్టింగ్ ద కూలింగ్ లెవెల్ ఫర్ యువర్ ఫ్రిడ్జ్. సో ఫ్రిడ్జ్లో కూలింగ్ లెవెల్ హై ఆ లో అనేది పెట్టేస్తారు, అండ్ దట్ ఈస్ మెయింటైన్ automatically. Automatically means somebody is actually monitoring the temperature inside your fridge, and if it goes high, then it is automatically cooled, and if it is goes low, it is maintained at a certain level. So somebody is monitoring. Who is monitoring all this means there will be a microcontroller inside your fridge also. Okay, right? So they are used in automatically controlled products and devices, and in automobile systems, that means in your car and bike, and also in medical devices. Okay, so everywhere in office machines, that is printers, remote controls, appliances, toys, and everywhere the microcontrollers are used. And the devices in which this microcontroller is used, okay, to perform a specific task, those devices are actually called embedded systems. Embedded systems. So this is, what is this embedded system? Actually the branch name, embedded system engineering. Okay, so what is embedded system? So right, the appliances where you are using the microcontroller to perform a certain task are called embedded systems, right? So this forms the basic subject of your branch actually. So microcontrollers. So these, if you can see the practical microcontrollers, the names of the microcontrollers are 8051. This is one type of microcontroller, and that is what we are studying throughout this subject. And other microcontrollers, if you see, that is AVR microcontroller, PIC microcontroller. And microcontroller has a lot of importance, because whatever the device that we see today, whether you find it in home or office, or in automobile, that is in your car or bike, or in remote controls or anywhere. Okay, Almost all the device contains at least one microcontroller in it to perform a certain specific task for the appliance. So that is the much importance there for your microcontroller. And you can see the real microcontroller IC I have placed at the bottom, right? So it is a 40 pin, 20 pins on this side, 20 pins on that side. So these are called pins where you can connect the other devices. And you can see what is the size of this microcontroller. The scale is given here. So it is around 3 centimeters. 3 centimeters. Okay, the device is very small, and you can see that this is a 3 centimeter IC, and it, though it is a 3 centimeter only, it contains all the circuits like CPU, RAM, and ROM, and everything, IO, etc., etc. Okay, and we will study in detail about this microcontroller throughout our subject to find and to learn how to use it in our practical applications, right? So next we'll see the differences between the microprocessor and a microcontroller. I told you that what is a microprocessor and what is a microcontroller. So here in the first slide I said that the microprocessor is, it's a CPU, but it's built on a single IC. Okay, instead of all these different circuits, if it is built on a single IC, the CPU itself is called as microprocessor. And if a computer uses the microprocessor as a CPU, then we said that it is a microcomputer, and we studied a block diagram description of the microcomputer. And next we have seen what is microcontroller. There we said that the microcontroller is, it's also an IC, but it contains microprocessor, not only microprocessor, but it also contains other circuits along with microprocessor. Okay, so microprocessor తో పాటుగా మెమరీ అండ్ అదర్ సర్క్యూట్స్ అన్నీ ఒక ఐసీలో ఉంటే then it is called as microcontroller. Okay, and this microcontroller is more useful in appliances. Okay, so here we'll see some differences, comparison between microprocessor and a microcontroller. So there is a block diagram at the top. Okay, you can see on microprocessor side, you'll see there is a block called CPU in the middle, and the CPU itself is your microprocessor. The CPU built on a single IC. So this one block itself is actually called as IC. So CPU itself is microprocessor, and you can see that this microprocessor contains only ALU, CU, and register array only. ALU, CU, and register array only inside this CPU. That what we have shown here. The microprocessor contains ALU, CU, and the register array only. Okay, inside your microprocessor. But what a microcontroller contain? A microcontroller contains not only microprocessor, but along with it, it also contains a memory, that is RAM and ROM. It also contains input and output ports. Ports means connecting pins, ports, and also peripheral devices. Some other devices like timers, counters, AD converters, etc. all are present inside your microcontroller. Right. So this is the first point of difference. What there inside your microprocessor, what is there inside your microcontroller. So inside a microprocessor you have ALU, CU, and register array, but inside microcontroller we have microprocessor. This entire microprocessor is there inside your microcontroller. Along with that microprocessor, it also has all these memory, IO ports, and peripheral devices. Okay, so and the second point of comparison is that, so in order to function as a computer, okay, as a full computer, the microprocessor, so that means the CPU, it requires a lot of other things like input, output, and RAM, ROM, timers, etc. Okay, so in order to function as a full computer, it requires a lot of additional parts like this. Okay, but for a microcontroller, you can see that the microcontroller is this, where it contains all, so it does not require any additional parts to function as a computer, right? So microcontroller on its own can function as a computer. So on the third comparison, you can see on the microprocessor side, so microprocessors are actually used in your personal computers. So that means they are actually perform a number of different tasks, maybe one after the other, maybe parallelly also. That means uh, what is mean by this multiple task means, uh, by using microprocessor, you can open the computer and you can listen to the songs. At the same time, you can do some typing work. Okay, you can type the documents at the same time. That means you are doing multiple tasks at the same time, or you can perform the multiple tasks. That means at one time you can listen the songs, and after that you can type the documents. That means you are doing different tasks, right? Then that is possible with your microprocessor, and it will have very high processing power. That means in order to do these multiple tasks, it should have a lot of processing power. That means uh, parallelly it has to process the songs, parallelly it has to process your documents, so it will have higher processing power. Whereas to see with respect to microcontroller, the microcontroller performs only specific task, only one single task, and since it performs only one single task, it will have lower processing power. So the ability to process the data is less for your microcontroller than your microprocessor. And coming to fourth point of comparison, microprocessor systems are heavier and costlier, because microprocessor systems ante, what you will see here, there is a CPU along with CPU is a microprocessor actually. So microprocessor, it also requires other different additional parts, and when you using microprocessor in a system, that means in a appliance, not only you require microprocessor, but you also requires all these parts. And if you are connecting all those parts, the microprocessor systems will become heavier. That means the weight increases, okay, and the cost also increases, because you have to buy all these parts separately. Okay, so microprocessor based systems are heavier and costlier. Okay, and coming to the microcontroller based systems are lighter and cheaper. Why they are lighter and cheaper? Because all that required to function as a computer are built on a single IC. The single IC that you are seeing here is of some 3 centimeters length, okay, which is very small. Okay, so the microcontroller based systems are lighter and cheaper also. Okay, and coming to application, where you are using microprocessor, you are using normally it in your personal computers. That means the computers you are seeing there, you are actually using the microprocessor as CPU. But where your microcontrollers are used, so microcontrollers are used in so-called embedded systems. Embedded system is the appliances where the microcontroller is used to perform one particular task. They are called embedded systems. And coming to the next topic, it is microcontroller applications. What are the various places where you are actually using your microcontroller? Okay, so a small diagram is shown here. These are the devices, a small number of devices shown. Okay, actually you have a lot of other devices where you will be using the microcontrollers inside, okay, to perform a specific task. So to name a few, we have home appliances, home appliances like your fridge, AC, washing machine, and TV, and also office appliances like your printers, okay, and telecommunication applications like your mobile phones, etc. And automotive industries means that is used inside your car, inside your bike, okay. And biomedical system means they are present in variety of number of medical equipment, and also they are present in equipment like your thermometers, etc. Okay, so these are the various applications or you can say, I can say that there is no appliance or a device today which is not at all using any single microcontroller. That means every device uses at least one microcontroller, okay. And for example, some few of the devices may use some 20 to 30 microcontrollers to perform a number of tasks required for the operation of the appliance, okay. So what we have seen in today's class is, right, we have seen what is a microcomputer and described the microcomputer from block diagram point of view and stated the function of each block, and also seen that what is a microcontroller, and we have found some comparison between microcontroller and microprocessor and seen some applications of microcontroller. Thank you, and this will be the end of today's class.